Vectors Part 2b, Addition, Subtraction and Gradient of Vectors. Question number 3. Given the following, I have vector AB and vector B to C, and they asked me to find vector AC. Now, how am I going to find this vector? My objective is to go from A to reach the final destination at C. Now, where can I travel to given from A? A allows me to travel to B, so I call them vector 1, 2. And then from B itself, I can travel to C. Then this column vector, so I'll do an addition of 3, negative 3, 4. And from this, I can get the vector A to C, meaning I started off at A, I traveled in between, and I ended off at C. So that's why this is vector AC. Then adding these vectors up, I'll get negative 2, 6. Now please take note that this is not a fraction or anything. Do not simplify it, and do not say that, oh, there's a common factor 2, then I cancel it, become negative 1, 3. There's no such thing. So leave it as the vector. Okay. Next one, part B. To travel from P to Q is 1, 4. Q to R is 8, 6. They asked me to find the vector P to R. That means I'm going to start at the location P. Where can I travel to? My information gives me that P can travel to Q. Now, starting from Q, I'm going to continue my journey. Where can I travel to now? Q to R. Then I started off at P and I end off at R. So that gives me the vector PR. And using our vector column vectors, this will be 1, 4, 8, 6. And I'll get 9, 10. Have you gotten the answer? Next one, part C. How would you like to find the answer? I need to travel from W to Y. That's my objective. So I'm going to start off with W. And where can I go to? I can travel to X. And from X, I'm going to continue my journey. And where can I go to now? Only to Y. So I started off at X, AW, end off at Y. That gives me a vector WY. So using our column vectors, we'll have negative 1, 1 and 2, negative 3. We'll add up to a total of 1, negative 2. This will be the answer. Let's try the next question. Now focus over here. They want us to find E to F, right? So I'm going to start off at E and travel finally to reach F. So from E, where can I go to? Oh, E is only related to D. So I'm going to travel from E to D. And then, where else can D go to? I'm going to start off at D. And now I can travel to F. Is related. So I'm going to use this vector. I'm starting off at E, end off at destination F. So this will be EF. But now let's try to find these vectors. This is ED, but I'm given DE. What's the relationship between the two of them? They are opposite in direction. So if I have opposite in direction, they are negative vectors. That means originally is 2, negative 3. Now you become negative 2, positive 3. Adding on to my vector DEF, 4, 5. And that will give me the answer 2, 8. Remember, do not simplify the column vector. So now this is the answer. Let's try the next question. Part E. Question gives us a JK, LK, and they ask me to find JL. So I'm going to start off at J, end off at L. Where can I go to? From J, the only point that's related information given to me is to travel to K. And then, if that's the case, I must start off with K now. Okay, I'm at the same interchange at K, so now I need to change another bus. Where can K go to? K can travel to L. So I will have L over here. So now I started with J, ended with L. That will give me the vector JL. And what do I know about JK? JK is 5, negative 5. No problem. But what is K to L? I only have the vector L to K. How are they related to each other? Well, they are in the opposite direction. If they are in the opposite direction, what can you tell me about the vectors? They are negative vectors. So now this is negative 8, it will become positive 8. This is negative 9, it will become positive 9. And adding up the answers, we'll be able to get 13, 4. Have you gotten the answer? Would you like to try F on your own first? Have you gotten the answer? Let's try the next part of the question, G. Now I'm given the following and I need to find as the vector S to V. So starting from S, I'm going to travel to reach the final destination at V. So where can S go to? I'm going to start at S and I'm going to travel, the only place that links me to is T. So from station S, I take a bus to reach station T. Now at station T, where can I travel to now? Station T brings me to the location at U. So I can only travel from T to U. Now I'm still at the location U. Where can I go to? Location, final destination V. So in this case, let us add up all the different vectors. S to T and T to U plus U to V. And that will give us a total of Have you gotten the answer? Now let's try for H. Opposite in direction, we have a negative vector. zy and yz are opposite in direction, we will have negative vector. And simplifying, we'll be able to get the answer. Have you gotten the answer? Up next, we are going to talk about the gradient of vectors. Before we begin to do the different questions, let us do some understanding of the concepts. Now, for example, if I have the vector A to B, and let's say AB is the column vector 4, 3. So it means I travel 4 units on the x-axis direction, and I have 3 units on the y-axis direction, and this is perpendicular. Now if this is the case, and now we are going to look at gradient of vectors. What is the gradient? Gradient is actually the rise over the run. So if I were to look at the diagram over here, what will be the rise? What's the height? The rise over here will be 3. And what's the run? The run will be 4 units. So in this case, the gradient will be 3 over 4. That means I'm going to take the y value divided by the x value, and that will give me the gradient of the vector. Using this concept, now let's take a look at question 4a. Given that mm is this vector, find the gradient. So if that's the case, gradient of mn will be taking the rise over the run, which is the y value over the x value. That will be 4. We would like to try to find out the rest of the answers. What will be the gradient of yz? We will have the rise over the run, or the y value over the x value. That means negative 5. Last but not least, what's the gradient of yz? This will be taking the rise over the run, which is the y value, negative 5, over the x value, 2. And negative, this will be the answer, or negative 2.5. Have you gotten the answer? Question number 5. In this diagram, ABCD is a parallelogram. What's so special about parallelogram? We have opposite sides that are equal vectors. Okay, so there's quite a couple of equal vectors over here. But now they come up with a point E that's inside the parallelogram. And they tell me that vector E to A in this direction is given as A. And E to B in this direction is the vector B. E to C is C, and E to D. Okay, so now we have a couple of different vectors over here. Now we have to find what is the vector for BC. How can I start to travel from B to C? I'm going to start with B, and I need to end up with C. But where can B go to? In this case, B can only relate me to, B can only have one vector that links me to E. So I'll start from B, and I'll travel to the point E. Now I'm at point E. Where can I go to? Well, I can go to the point C and end off at C. What are all these vectors? So the resultant means I will start at B, end off at C. And this will be the vector BC. Now B to E is going in the opposite direction. So in this case, I will have a negative vector. This will be negative b. Remember to put the roller skates. Without the roller skates, this will be an algebra. The whole question will be considered as wrong. Then now I'm going to move on to E to C. E to C is in the same direction given, so it's just the vector C. Hence, this will be the answer. Now, how do I find D to A? I'm going to start off at point D. Where can I travel to? From point D, I have only the vector that I know of over here. This is D to E. So I shall move to E then. And from point E, I need to go to A. So there is a vector D to A over here. So I'll start off at D and end off at A. And this will be my final vector, D to A. So when I go from D to E, it's going in the opposite direction. So hence, this will be a negative D on roller skates. And E to A over here. Now, E to A is given by the vector A. It's going in the same direction. So I shall have this. Now, they ask us to use this answer. Hence, using this answer to show that A plus C is equals to B plus D. What do we have down here in our vectors? Our vectors have BC. Where is BC? Oh, BC is over here. It's going from B to C, going in the upwards direction. But I have the other vector D to A. This is going in the downwards direction. What is the relationship between BC and DA? They are equal in magnitude but opposite in direction. Hence, they are negative vectors of each other. So for part B, I can start off with BC is the negative of DA. Well, BC is represented by negative B vector plus vector C. And this will be equals to the negative of dA, which is negative D plus A, vector A. Let's simplify this a little bit. We have negative B plus C. And this one over here, we'll change the sign to be D minus A. Is this the format that they want? Oh no, they want this one over here, A plus C. How can I put A and C together? Well, I can shift this over to the left hand side. This is a minus A. If I shift over to the left hand side, I'll get a positive A. Plus C stays here. And on this side, D can stay here. And I will want negative B vector to come over to the right hand side. And that will become B plus D. Now this is what they wanted shown. Have you gotten the answer? Last few questions. Now in question 6a, I'm given mn to be this column vector. Now they tell me that find the new column vector of mn after it is translated. What do you mean by translated? Translated by this vector, meaning I have moved my original vector by adding a negative 6 to my x units direction and a positive 4 on my y units direction. What does that mean? So originally mn is given to be negative 1, negative 4. I'm going to shift it by adding a number of units. So I'll add a negative 6 to the x value and a 4 to the y value. So now mn changes to become negative 7 and 0. So the new column vector for mn will be this final answer. Now let's look at part B. Given that AB is translated to MN, so from AB, I'm going to move it to MN by a particular vector. So in the process, what does it mean? I'm going to shift a negative 6 units on my x-axis direction and 4 units on my y-axis direction. So given that mn is equals to 2, negative 4, they asked me to find AB. Where did I start from originally? I started off from AB. But I do not know what's AB, so I'm going to leave it. And then I shifted by a vector, translation vector, negative 6, 4. And that gives me mn. mn is now 2, negative 4. How can I find the vector AB? I can do a subtraction. So AB over here will be equals to 2, negative 4. I'm going to subtract away the translation vector, minus 6, 4, in order to find AB. So that means I will get 2 plus 6, 8, negative 8. Now the word translation is not commonly used in vector questions, but it does come out once in a while. So we still need to be aware of this word called translate. Translate means to move by a certain number of units on the x-axis direction and a certain number of units on the y-axis direction. Now we've come to the end of this part of the chapter. Up next, we'll be learning on the scalar multiple of vectors.